Good day, everyone. Welcome to Elementary Theory of Numbers. Our topic is about linear Diophantine equation. I will be your discussant for LDE Part 1, Ms. Jennifer Rivera. The linear Diophantine equation AX plus BY equals C was named after the Greek mathematician Diophantus. Almost nothing is known about Diophantus, other than that he lived in Alexandria around 250 AD. He's sometimes known as the father of algebra, as he wrote Arithmetica, which is the earliest known book on algebra. It contains the first systematic use of mathematical notation to represent unknowns in equations and powers of these unknowns. The linear Diophantine equation theorem. The equation AX plus BY equals C has solutions if and only if D divides C, where GCD, or the greatest common divisor of A and B, equals D. If the equation has a solution, then all other solutions are of the form x equals c over d times x sub 0 plus b over d times t, and y equals c over d times y sub 0 minus a over t times t, where t is an element of z, which is the mathematical symbol for a set of integers. Where x sub 0 and y sub 0 satisfy the equation a times x sub 0 plus b times y sub 0 equals d. Proof. Suppose xy is a solution, then ax plus by equals c as the equation 1, and ax sub 0 plus by sub 0 equals d as the equation 2. Multiply r in equation 2. We'll come up with the equation 3, a r x sub 0 plus b r y sub 0 equals r d. That is also equal to c. Let's equate equation 1 and equation 2. We have ax plus by. The equation 3 equals a r x sub 0 plus b r y sub 0. Then transpose to combine like terms. Ax minus ar x sub 0 equals br y sub 0 minus by as the equation 4. Combine like terms and divide d on both sides. Thus, a over d times x minus r x sub 0 equals b over d times r y sub 0 minus y is the equation 5. From the equation 5, a over d times x minus r x sub 0 equals b over d times r y sub 0 minus y. Now let's divide to get the general solution for y. A over d divides b over d times r y sub 0 minus y equals a over d divides b over d, or a over d divides ry sub 0 minus y. However, a over d and b over d equals 1. So, a over d times t equals ry sub 0 minus y for some integer t, and r equals c over d. Thus, the general solution for y is c over d times y sub 0 minus a over d times t, and that is the equation 6. Using equation 6 to 5, since y equals c over d times y sub 0 minus a over d times t, and equation 5 is a over d times x minus r x sub 0 equals b over d times r y sub 0 minus y, substitute r with c over d and r y sub 0 minus y to a over d. Then, cancel a over d to both sides of the equation. So we have x minus c over d times x sub 0 equals b over d times d. Then, transpose c over d to get the general solution of x. X equals c over d times x sub 0 plus b over d times d. End of proof.